Hello, and welcome to another Algebra 1 lesson. This is lesson 6.2. Our objectives today: find nth roots, so not just square roots, but cube roots and fourth roots and fifth roots, find nth roots, and evaluate expressions with rational exponents. Rational exponents means our exponents aren't just going to be integers, but they might be fractions. Finding nth roots. You can extend the concept of a square root to other types of roots. For example, 2 is a cube root of 8 because 2 cubed equals 8, and 3 is the fourth root of 81 because 3 to the fourth is 81. In general, for an integer n greater than 1, if b to the n equals a, then b is an nth root of a. B is the nth root of a. So if you start with this one and you do the nth root of both sides, the nth root of b to the n, when these two numbers match, they undo each other, raising something to a power and doing that same type of root. Those undo each other, so we get b equals the nth root of a. That's what this was saying. If b to the n equals a, then b is an nth root of a. An nth root of a is written as nth root of a, where the expression n radical a is called a radical, and n is the index of the radical. So this number here is an index, this number here was an exponent. A lot of times I will tuck that n in here just to make sure it doesn't look like it belongs somewhere else. You don't want two of them though. So you can put it right on top of that, or you can tuck it in that little corner. Real nth roots. Let n be an integer greater than 1, and let a be a real number. If n is odd, then a has one real nth root. So if we're doing a cube root or a fifth root or a seventh root, but the index is an odd number, then it has one real root. If n is even, and a is greater than 0, then a has two real nth roots. That's like if we were doing, we can do the plus and minus square root of 4. Square roots have two answers, positive and negative 2, because 2 squared is 4 and negative 2 squared is also 4. So if n is even, we get two real nth roots. If n is even and a is 0, then a has one real root, it's just 0. If n is even and a is less than 0, then a has no real nth roots. So in other words, the square root of negative 4 is no real solution. Or no real, not real. It's not a real number. Okay, rewrite using rational exponents. So if we have the nth root of a equals a to the 1n, a square root actually has an invisible 2. So when we have a radical with no index written here, it's really just a 2. And this 15 has a 1, so this gives us 15 to the 1 over n power, 1 over n power. So that's 1/2. Okay, following this example here. Cube root. Well, this is 7 squared. So this is 7. This index becomes your denominator. But we had an exponent here, so we'll put that there. So that's 7 to the 2/3 power. So really, we want to generalize it with an exponent in here, a to the m. If we're finding the nth root of that, that is equal to a to the m over n power. Make sure you add this into your notes. This will come in handy all chapter long. All right, rewrite using radicals, x to the 3/4. So it is an exponent. We're going to change it to a radical. The x goes in here. We have to put a number here for the index and a number here for the exponent. The denominator is our index. The numerator is our exponent here. All right, give it a try. Try number 4. Okay, so the denominator goes here, the numerator goes here, but anything to the 1 power, we can just let that exponent of a 1 go invisible. And a square root, the index is 2, that's just the typical root that we usually do, which is a square root. We can let that 2 go invisible. So this one is just square root of 3. That means 3 to the 1/2 power says the same thing as the square root of 3. All right, going back and forth from exponents to radical form. Find the indicated real nth root of a. So we want to find the nth root of a. But we're going to use this a and n that they gave us. So the nth root, so the cube root of a. Now, a lot of calculators have an nth root. It'll show up as an x with a radical. But we can also break this down into prime factors. 27 is 9 times 3. 9 is 3 times 3. So this is 3 3s. And remember, when we're doing cube roots, we're looking for sets of 3. The cube root of a negative is a negative. Cube root of a positive is a positive. This is a negative number, and we have 1 set of 3. So that's -3 for an answer. -3 times -3 times -3 gives us -27. So the cube root of -27 is -3. Next one. Nth root of a. Put the n out here. Put the a in here. 16. 16 is 2 times 2 times 2 times 2. So the 4th root undoes the 4th power, and we just get 2 as an answer. When we're doing a 4th root, you're asking yourself, how many sets of 4 2s are there in this case? So we've done it before where we wrote it out and we looked for sets of whatever it was we were taking the radical of. 4th root of 2. 1, 2, 3, 4. We have 1 set of 4, so a 2 pops out. Well, with this new information, we can also use the fact that this is equal to a to the m divided by n. So if we have the 4th root of 2 to the 4th power, that can be written in exponential form as 2 to the power of 4 over 4, which is 2 to the 1st power, equals 2, same as I got before. More than one approach. Remember, you're going to want to look for this button on a calculator to help you out, if nothing else, to at least check your answers. And that's example 1. All right, let's try a couple more. Nth root of a, cube root of -125. So what number cubed gives us 125? -125. Well, that would be -5. I forgot something very important. Backing up. The nth roots. Plus and minus. Plus and minus. When n is even, it has two real nth roots. They want us doing both of them. So this is a plus and minus 2, a positive 2 and a negative 2. A positive 2 and a negative 2. So we needed to do a plus and minus here. All right, so we're going to do a plus and minus 6th root of 64. All right, what is 64 in prime numbers? 2 times 2 times 2 is 8. I could do 4 and 2, and then 2 and 2. Sometimes I like to take that shortcut and just go to 3 2s right away. But that is 6 2s. So the 6th root of 2 to the 6th is 2 to the 6 over 6 power, which is just 2. But we want the positive and the negative. It's an even root, it's an even index, so the answers are 2 and negative 2, which we usually will just write as plus and minus 2. Remember, you can find these monitoring progress problems in your ebook. If n is even and a is less than 0, then a has no real nth roots. That's going to come up in one of these examples. So if we are taking a square root or a 4th root of a negative number, there is no real nth roots, so no real answer, no real solution. So this is the cube root of negative 8. Negative 8 is negative 2 times negative 2 times negative 2. So negative 2 to the 3/3 power is 1, or the exponent is 1. The final answer is negative 2. Okay, this one, cube root of 8. Cube root of 8 is 2, and then we have this negative outside, so this one's also negative 2. So we can do cube roots of a negative number, or we can even have it outside. But it's not the same with the nth roots when the n is even. So the 4th root of 16, or 16 to the 1/4 power, that's 2 to the 4th power to the 1/4 power. Because 2 times 2 times 2 times 2 is 16. That gives us 2 to the 4/4 power, which is 2 to the 1. It's just 2. We also could have written this 1/4 power as a 4th root of 16. So that it's a 4th root of 2 to the 4th, which is 2. Same answer either way. No contradictions. That's why I love math. It never argues with itself. Both methods agree on the same answer. All right, and this one, this is a 4th root of negative 16. There is not a number that we can raise to the 4th power and get a negative answer. There is no real nth roots, so no real root. It's not a real number. All right, and there's example 2. So you have to be careful with the even roots, square root, 4th root, 6th root. Odd roots like cube root, 3rd root, 5th root, 7th root, those can be negative, and then you just get a negative answer. If it's positive, you get a positive answer. It's just these even ones that we have to be more careful with. Rational exponents. Let a to the 1 over n be an nth root of a, and let m be a positive integer. Here it is, a to the m over n equals a to the 1/n m, which is the nth root of a to the m. So that is what I actually had to write down on a previous page. We wrote it like this. So this was the nth root of a to the m power. Okay, give it a minute, write these down. We actually did these earlier. Let's see if you can do it on your own this time. Rewrite them in the other way. The radical ones you want to write just using the exponents, and the exponent ones you want to rewrite using radicals. On your mark, get set, go. Pause your video for about 1 minute to 1.5 minutes. Write down your answer and then restart your video to check. Check your answers. Hopefully you got them this time. Moving on. Evaluate expressions with rational exponents. Evaluate 16 to the 3/4 power. Okay, several different ways we can do this. We can change it into a radical, or we can just use exponents. But we're going to use a lot of prime factorization, a lot of factor trees. So let's break down 16 and 27 and break those down into prime factors. On your mark, get set, go. All right, 16 is 2 times 2 times 2 times 2. So that is 2 to the 4th power. Earlier in this chapter, we also learned our exponent rules. And we learned that when we raise a power to a power, we are multiplying these two numbers. This one's a fraction, so I want to make this exponent also look like a fraction. So we're multiplying these together. That would be 12, because 4 times 3 is 12, 1 times 4 is 4. That's our new exponent. But what is 12 divided by 4? 3. And then 2 cubed is 2 times 2 times 2. 2 times 2 is 4. Times another 2 is 8. And that's our final answer. Let's try this one, 27. Break it down. Now, did you notice when I multiplied these two fractions, we got 12 fours, but this one had a 4 on top, this one had a 4 on the bottom. We could have just canceled those out because 4 divided by 4 is 1. And then we just have a 3, and we could have skipped over that step. Well, we can do that with this one. This is 12 over 3, but we have a 3 on the top and the bottom. So those 3 divided by 3 is 1. 4 divided by 1 is 4. So we get 3 to the 4th power. And then 3 times 3 times 3 times 3. I think of this kind of like a factor tree backwards. 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is, 81. Look at that. Or you could have gone in order. 3 times 3 is 9. Times another 3 is 27. And then 27 times 3 would also give you 81. So on this side over here is kind of my scratch work. Here's my actual answers. If I were turning in a paper showing my work, I would just show this part. This would be on my scratch paper I didn't turn in. And that's example 3. Right, here's some more. If you want more practice, you can go to the ebook or your dynamic book, I think it might be called. and you click on the menu in the upper left-hand corner that says menu. It actually opens a table of contents, and then you would go to 6.2, open up that lesson, and find these monitoring progress problems. And it allows you to type in an answer and then hit check and see if you're right. Example 4. Ooh, word problem. The radius r of a sphere is given by the equation r equals 3v divided by 4 pi to the 1/3 power, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Oh, that's a big beach ball. Use 3.14 for pi. The volume is 113 cubic feet. That's the volume. And they gave us an equation where v is the volume and r is the radius. So we're going to use the equation they gave us. But v, they gave us a number for v. We want to put that in. So 3 times 113 over 4 times pi. They've instructed us to use 3.14. And 3v over 4 pi, all of that needs to be raised to the 1/3 power. Okay, let's do this stuff inside first. Grab a calculator. Three times 113, 4 times 3.14, wrote that down. We're going to divide these two. We don't want to do any rounding before we really have to. So I have this number on my calculator. What I'm going to do is leave that number on my calculator. It's already there, and I'm going to use that up arrow. It's called a caret, but it's what we press to get exponents. And then I'm going to tell it, so it'll print answer, ANS for previous answer. And then it has this thing that popped up. I'm going to tell it parentheses 1 divided by 3. Parentheses 1 divided by, that's how I get my 1/3 power. I want to do parentheses around it though. 1 divided by 3. And we get 2.9996. And then it keeps going. Well, so pretty much that's 3. So our radius is approximately 3. What were we measuring in? This was cubic feet. 3 feet. Okay, so the radius, remember, goes from the middle to the outside. So if that's 3 feet, what's the diameter? How far all the way across? Because you might be thinking 3 feet, that's not very big. Well, 3 feet's the radius. So what's the diameter? How tall is this ball if you're standing next to it? 6 feet. 6 feet tall. That's awesome. So if you're taller than 6 feet, you'd be taller than it. But for those of us shorter than 6 feet, that ball would be taller, would stand up higher than we are tall. So it's about 3 feet for the radius, 6 feet for the diameter. Very cool. We used a 1/3 exponent for that. Look at that. Response log. Select from one of these sentence starters. I figured these out because, or I feel confident about, or at first I thought, but now I think. So write down some thoughts about this lesson. Fraction exponents, that was kind of weird and new. Okay, write that down in your notes, and then we'll go to Big Ideas assignment 6.2. All right, you want to keep your 6.1 notes close by with your rules of exponents, because now they apply to fraction exponents. And remember that a to the m over n is the same as the nth root of a to the m. This is the big new thing that we learned today. That also means like the square root of x means x is actually being raised to a 1/2 power. So square roots are really just 1/2 exponents. All right, guys, have a great day. Thanks for watching. Ask questions during class if you need some extra help, or send an email to your teacher. Have a great day.